We begin with similar triangles today. To understand greater about similar triangles, it is very important for us to know Thales. Further, we will study two important properties that Thales had formulated, the BPT, which is also known as basic proportionality theorem, and the converse of BPT. Beginning with knowing Thales, he was again a Greek philosopher and a mathematician, and he was a natural philosopher. That is why he did a lot of his work on planets and stars, and he was the one who correctly predicted a solar eclipse. Please remember that time we did not have many scientific instruments, and he was able to do that. In his era, he was found to be a great influential teacher. Thales was a revolutionary thinker who impressed his contemporaries by being able to calculate the height of a great pyramid of Egypt. He is the first recorded person who tried to explain phenomena like earthquakes by rational rather than by spiritual means. Philosophy, science, and mathematics were more important to Thales than even his family or wealth. Very little is known about his family life. I somehow find this quote very interesting by Thales, and this quote actually helps us know Thales better. Nothing is more active than thought, for it travels over the universe, and nothing is stronger than necessity, for all must submit to it. So, in his first phrase of this quote, we can see how Thale was able to connect nature with mathematics and the universe with mathematics. And at the same time, he was very practical because he was talking about necessity and how necessity made him find and formulate what he did. Another important thing Thales very often said was that know thyself. It is very, very important. So, and he called that as a golden rule of leadership. Through self analysis, you can identify your personal insecurities, self deceptions, and other weaknesses, and thus develop ways to overcome them. Another important thing that Thales said, and it is very relevant in the era that we are living right now, all human sufferings come from ignorance. If we would have been more aware of how we are destroying nature, we wouldn't have come to what we have come to today. So, now getting to the mathematical part of Thales' life, the first thing that we are doing is the BPT, also known as basic proportionality theorem. Now, to talk about proportion first, if I just look at this fraction, AD upon DB, this is known as a ratio, and AE upon EC is another ratio. However, when we put one ratio equal to another ratio, together this format becomes a proportion. So Thales said that if we take a triangle and we draw a parallel line to any of its side, then that parallel line divides the remaining sides in the same proportion. Implies if this line is passing through AB and AC and is parallel to BC, then AD upon DB will be same as AE upon EC. This is something that Thales had stated in his basic proportionality theorem, famously also known as Thales theorem after his name. So in this triangle, it is given to us that DE is parallel to BC, and we need to prove this. We are now going to study the proof of this theorem. So over here, there are two perpendiculars drawn, one from E to AB, another from D to AC. After drawing these perpendiculars, there are certain formulae that we use from the previous learning that we have. We know that area of triangle is half base into height. So we first take area of triangle ADE, keeping AD as the base. When we keep AD as the base, EF becomes the perpendicular. Hence we have area of triangle ADE as half AD into EF. Now we take triangle DBE. Now triangle DBE is an obtuse triangle here. And please remember, in an obtuse triangle, the height lies outside the triangle. So this triangle over here, which is shaded, DB is the base. However, E is the vertex of the triangle, and the altitude that is made on DB comes outside DB. Therefore, that becomes the height. So EF is the height. So we have area of DBE as half DB into EF. When we put these two areas in the ratio form, half and half cancel, EF and EF cancel. So we are left with AD upon DB as the ratio of these two areas of these two triangles. In exactly the similar manner, we take again the two areas. However, this time when we consider the area of triangle ADE, we take AE as the base. So DG becomes the perpendicular. So we get again these ratios equal to this. So ratio of the areas of these two triangles is equal to the ratio of AE upon AE and EC. Now, when we compare the left hand sides of equation 1 and 2, the numerators are same, area ADE, area ADE. And when we look at the denominator, that is DBE and DCE, we can see over here that DE and DE are the two common alphabets. So that becomes the common base for these two shaded triangles. So these two shaded triangles lie between on the common base and between the same parallel lines. Hence, their areas are equal. So, numerator is equal to numerator because it is the same triangle that we are talking about. Denominator is equal to denominator because these are the two triangles on the same base between the same parallels. Since the entire left hand side is equal to the entire left hand side, hence right hand side will be equal to the right hand side. Hence we have proved this theorem. Now we'll get on to the converse of PPT. So when we look at the converse of PPT, we have just the opposite. Now the question says that if a line is cutting two sides of a triangle, breaking it into the same proportion, that means DE is some line, it is cutting AB and AC at points D and E such that AD upon DB is equal to AE upon EC. So we need to prove that in such case DE becomes parallel to BC. This proof we begin with a contradiction. So we say, all right, we have to prove that DE is parallel to BC. So since we do not know whether DE is parallel to BC, let us take another line that is parallel to BC. Please understand over here, you've done the pair of linear equations in two variables, that if I have two lines, either they will be parallel or they will intersect. If these are two distinct lines, they are not coincident lines, right? So over here, since DE is not parallel to BC given to us, we will say, all right, there will be some line in this plane which will be parallel to BC, and we are assuming DE dash to be parallel to BC. So this is by construction or assumption we take. Now, since DE dash is parallel to BC, so using BPT, we can have AD upon DB is equal to AE dash upon E dash C, applying the BPT. So this is an application of BPT that we are using. Now, comparing what is given to us and what we have proved using this assumption, the left hand side is same as left hand side. Therefore, the right hand sides have to become equal. Now, so we have sorry, we have these right hand sides equal to one another. We know that equals can be added to equals. So we are adding 1 on this side and 1 on this side, getting this. We take an LCM here. So the LCM becomes EC. This becomes, the numerator becomes AE plus EC because EC will multiply with 1. Similarly, on the right hand side, E dash C is the LCM. So we get AE dash plus E dash C over here. Now, looking at the figure, AE plus EC, that means AE plus EC is equal to AC. So the numerator becomes AC over here. The new denominator stays as EC. On the right hand side, we have AE dash plus E dash C, which also becomes equal to AC. So the numerator on the right hand side also becomes equal to AC, and the denominator stays as E dash C. Now, when we compare this proportion, the numerators are equal to each other. Hence, the denominators have to be equal to each other. So, EC becomes equal to E dash C. If EC and E dash C are equal and they are part of the same lines segment, then we conclude from here that E and E dash are not different points, but they are the same point. It is the same single point. So here when we write that E and E dash coincide, it basically means that these 2 points cannot be separate from each other. If these 2 points are not separate from each other, and we had taken DE dash parallel to BC, now we are saying that E and E dash are the same point. Hence, we prove that DE parallel to BC. So this is all that we have done for today. We have come to know about Thales, how his main passion was discovering mathematics in nature and universe, and then applying those principles that are already existing in the universe in a very practical way. When we went through BPT and converse of BPT, BPT is also known as Thales theorem, and this is known as converse of Thales theorem. Thales, these two theorems are named after his name. We have seen how practical Thales was despite his venture into the philosophy